Question number 3 on the video worksheet has a woman standing 1.5 meters from one end of a 6-meter long plank that has a mass of 70 kilograms. You need to solve for the tension in the 2 wires that are supporting it on either end. If she was standing right in the middle, then it would be pretty straightforward. It would just be the total mass divided times 9.8 divided by 2 would be the force in each wire. Because she's closer to one end, it will have a greater load. If she was standing right beside this wire, that would give you the greatest tension force here. So when you're solving, just keep that in mind. Always kind of think as a check, do these answers make sense? If you get a smaller force here, then you've known you've done something wrong. So this body is in equilibrium. We're going to treat this sort of like a teeter-totter, where if you let go of this end, these 2 loads rotate clockwise, and this tension force at B causes a rotation in the opposite direction. So the 2 clockwise rotational forces, or torques, must add up to give you the same magnitude as the counterclockwise rotational force. So this distance, 1.5 meters times 50 times 9.8, which is 490, so 1.5 times 490 is clockwise. 3 meters times 686 newtons, also clockwise. That must be equal to this 6-meter distance, which is perpendicular to this tension force, and that gives you the counterclockwise rotational force. So just to write that out, I'm going to do sum of the moments. Moments are torques. About A must be equal to 0. Same thing, moment torque. So 1.5 meters times 490 newtons plus 3 meters times 686 newtons must be equal to 6 meters times the tension force in wire connected to B. And that gives me a tension in B of 465.5 newtons. In the final answer, I would just write that as 466 or 470 newtons, but I'll leave it as 4 digits for now to make sure my check is nice and clean. There's 2 ways to solve for the tension force in A. I can either use the sum of the forces in the y direction equal to 0, or I can take moments or torques about B. I'm going to do sum of the forces in the y direction equal to 0. So that means these 2 tension forces must be equal to these 2 weights. So tension force A plus 465.5, those are the forces acting up, must be equal to 490 newtons plus 686 newtons. So when I do this plus this minus this, I get the tension force in A is 710.5 newtons. And these are both up. I think I'm just asking for the magnitude of the tension force, but still, those are 2 forces are up and these 2 forces are down. Forces up equal forces down. It's always a good idea to check. When I check it this time, I'm going to pretend I'm just solving for A instead of seeing, like putting the number in and seeing this left equal right. So I'm going to solve for the tension force in A by taking, I'll call it torques this time. Sum of the torques about B equal to 0. 6 meters minus 1.5, the woman is standing 4.5 meters away from end B. About this point, these 2 weights are causing counterclockwise torques, and the tension in Y is giving you a clockwise rotational force. So 4.5 times 490 plus 3 times 686 must be equal to 6 times the tension force at A. I'll just put that this is 3 meters. Again, to write that out, 4.5 meters times 490 newtons plus 3 meters times 686 newtons must be equal to 6 times the tension force in A. And sure enough, when you do this times this divided by 6, sorry, this plus this divided by 6, that gives you an answer of 710.5. Same answer you get when you do sum of the forces in the y direction. In your final answer, you would just say tension force in A, 711 newtons up, and tension force in B, 466 newtons up.